guys. Alright, well I'm out in the shop today and I've rearranged my base and we're getting ready to start mounting the linear rails to the y-axis. Now before we mount our linear rails, there are certain tolerances that we're going to have to follow in order to make sure that we get the accuracy and the results from the linear rail conversion that we are expecting. Or in the paperwork that I downloaded from HiWIN, there are certain tolerances that we need to try to follow for the RG series. And these are the three. The first one is parallelism. The maximum parallelism tolerance for the distance between rail and center line of rail to rail is this P measurement, and for the RG15, which is what we're going to be using on our X and Y axis, it's 5 microns. I know for sure that I need to have my datums parallel within 5 microns to start, otherwise there's no sense in starting to mount the rails. So I've checked these and it looks like, fortunately, I've got mine set to around 2 microns. Now I'm going to see if I can get a video of this while I'm trying to move it. It's extremely difficult to balance the magnetic base here and move it at the same time. So, and these are, you know, extremely sensitive. We're talking microns here, so hopefully you'll be able to see this in the video. Maybe I can get most of it in that shot right there. So you can see we're kind of at 0 now. I'm bouncing. Alright. There we go. Moving off a little bit there. Maybe 3 microns. And then it kind of goes back. It may just be me. Yeah, it looks like right in there. And then it goes back. So we're about 3 microns. And our tolerance is 5 microns. So I'm pretty happy. We can, I think once we get the rails mounted, it's going to change a little bit because the rails, of course, the rails aren't going to be, you know, wavy. They're going to be fairly straight. So we'll see. I'm going to get the master rail set, and then we will, of course, check all this as we go along. Some of the other tolerances are S1 here, which is our height tolerance, the distance between the bottom of one rail and the bottom of the other. Now, there's a formula that you need to go by, which is the distance between the center of one rail to the other times K, and K is, that is for light preload class. Medium preload class is 1.7 and heavy preload is 1.2. So depending on which class of rail you got, ours are Z0. We're going to use this 2.2 to 10 to the -4. Take this formula and put it into a spreadsheet here, and for each one's different for the X, Y, and the Z because of the distance between the rails. But for the Y-axis here, we need to be 0.04 millimeter, or a little bit, about 1,000, a little over 1,500 inches. That's for our height between rail to rail. Next is S2. S2 is the height of the 2 blocks, and S3 is the height between the front and the back block. Again, I did all these on a spreadsheet. For S2 and S3, it's about 2/10 on the X and about 3/10 on the Y and about 1.5 on the Z. The parallelism, this 5 microns, is by far probably the greatest tolerance that we need to try to maintain. Alright, so I'm going to get set up and we're going to start mounting the master rail on the Y-axis. Alright guys, so here we go. About ready to start mounting our linear rails. Now what I've got here is I've turned my base around so that I can reach this side, because I'm going to work on this side first. This is the master side. The rail has to be put on in a certain orientation. Hopefully you can see this right there. No, maybe not. Oh, there, maybe you can see it. Catch it just right there. There's some arrows, and they're pointing from the bottom of the word HiWIN up. And that is the side that is your master. There we go. Maybe you can see it there. That is the master side. So we need to make sure that that is up against our datum, which I have done. I've clamped it into position, and then I went and indicated it again and checked it. You can see that there's this 45 right here, or an angled edge right there. Well, there's also one up under here, and that is what I've got my indicator on. The indicator wasn't long enough to really reach around and get a good position, so that's where I've got it sitting. And I've indicated this and checked it. Let me get it. I'll show you what we got. You can see the indicator there. Well, at least maybe you can see part of it. Okay. Now I can only go from there to where I've got it clamped, but I did check both sides. We've got about the same result. You can see we're pretty straight right there. Now originally this was pushed out, and so I've got a clamp to squeeze it in. It looks like right there we're dead on straight. So I'm pretty happy and satisfied with that. I'm going to go ahead and start boring some holes and clamping this down. Now you'll remember that I borrowed the idea from another gentleman on these little bushings here, and so I took some bolts, turned them down so that they just fit inside the counter bore there, and then now I can center drill and bore out each of the bolt holes, and hopefully that'll keep everything lined up. Alright, so let me get set up and we'll bore a couple of holes and get some screws in there, and then we'll just continue on down and get this master rail mounted. Alright, I think it should have been set up better. I need to hit that with the shop vac. think that looks pretty good. Looks centered, which is good. Bushing worked. So should be able to just move on down, drill the next hole, next. Everything is still straight. Nothing moved. We should be good to go. Alright, so I'm going to bore these holes and then we'll get them tapped. Alright, well, I've got my master rail mounted. I've got one of the linear blocks on there. And if you remember, I used this dovetail edge here as a reference when I was setting my datum on the master rail. And so I want to go back and check this reference against the rail installation, make sure everything is good. A couple things I'm finding out, and of course I kind of expected it because I'm not using surfaces that I machined. I'm using surfaces that were already machined from the factory. But this edge right here, this dovetail flat, when you go to bolt this down, it you know, we're dealing with microns here, so it kind of moves a little bit. So it's not perfect. And the only way to get around that, I think, would be to you know, actually machine this datum in here, which if you don't have the ability to do that, then for me this was the best alternative. So let me spin this around. Boy, I tell you, with this epoxy fill, this base got really heavy. I've got the indicator here sitting on top of the linear block. Very, you can look at, you can see there's no movement, there's no wiggle back and forth, side to side. I mean, it is pretty rock solid. So I can imagine once you get 4 of these blocks on here, how nice this table is going to feel. So if you recall, when I installed the datums, I set up the datum, the master datum, using this as my reference plane. So I'm checking that against my linear rail setup here. I don't know if I can get a good shot of this. However, let's give it a shot. So we move it across here. Pretty happy with the results that I've got here. Next, we're going to install the sub rail. Alright guys, well, I've got my secondary or my sub rail in place. I've got it clamped on the ends, and I'm just trying to figure out how it needs to move. It actually looks pretty good. It's pushed out this way just a little bit on this end, needs to go in, and in the middle here needs to go in a little bit. Right now I'm pretty happy with where it's at. I'm going to go ahead and get a couple of screws in there, and then we'll work our way around. Alright guys, well, I've got my sub rail all mounted. I got to do the final install. I'm going to pull it all up, clean it real good, and put it back down, but I've got it mounted and pretty satisfied with where I'm at currently. So I've got the rail removed, and from drilling all these holes it leaves burrs and stuff, so I went back over it with a stone and just kind of removed all the burrs, made sure everything was nice and smooth. Just kind of cleaned everything up. I'm going to clean it all off again, and then I can start trying to set this rail. I want to check the height from this rail to the master rail, make sure that height is within tolerance. Alright, so now I am getting ready to permanently mount my sub rail. I've got my base back on the surface plate here, and I'm checking the height and comparing the height of the master rail to the sub rail. Alright guys, well I'm out here in the garage today and I'm continuing to work on my linear rail project. I had trouble finding some shim stock. Aluminum foil is about a half a thousandths or 5/10, and I need something a little bit smaller to get my rails set the way I want. So I found this shim stock here on eBay. This is onion skin, and it's really good. It's supposed to be oil resistant, water resistant, but it's real thin paper, basically some kind of paper, and they call it onion skin. So it's not cheap. It's about $10 a roll. These are 20-foot links, so hopefully I've got enough here to do my linear rail conversion. What I've done is I have went along and found my high spot, which happens to be this corner right here. So I set my 0 here, and then I went down and measured from the top of my surface plate to the top of my block here in 1-inch increments all the way down, and I marked down the readings. And what I'm going to do is, since that's the 0 point, I'm going to shim. Everything else is low, and I'm going to shim it up to this particular point, and then that way they should all be the same height all the way across. So I tried shimming it with the aluminum foil, which worked good. However, I don't have the right thicknesses to be able to do it the way I want and get it within the tolerance. It needs to be the height of this block and the height of this block needs to be within 3/10 of each other. So you can see right here I'm 2/10 low, and this is 0, so that's within tolerance. Here I'm 0, but this is 3.5/10, 2 and 5/10, 2 and 6/10. So this is out of tolerance right here. So I've got a little waviness in the rail, and I'm just out of the tolerance range. The highest is about 4/10 out of tolerance, so, which is actually really pretty good considering I'm mounting directly to the dovetail. Alright, so I'm going to start laying out some of this onion skin and see if we can't get these to be 0 all the way down. Okay, well, I have went back, lifted the rail up, and then I placed this onion skin up under here along with some of the original aluminum foil shim stock, and then I bolted it back down, and immediately I could tell that it just feels like it glides really smooth. There's no binding. Before it was kind of tight, and I thought, well, maybe it's just because the linear blocks are new, but it was actually because it was doing a little wave as it was going down. It dipped down a good half a thousandths here in the center, and so I used some of these readings here around 0.006, so I used some of the 0.0006 shim stock, this onion peel. It's actually very durable. I've never used this before, so I wasn't real sure. I didn't know if it was gonna. It is a paper-like substance, but it's almost like I don't know, a plastic of some sort. It's very durable. But the biggest chunk was right here in the center, and that was that to raise that up. Because some of these readings were just 1/10 out, I'm not going to be able to get it perfect because the smallest onion skin I had was 2/10. So I think if I can get it within the 3/10 from one side to the other, I think I'm doing good. So pretty satisfied with the way it turned out here. I'm going to go ahead and switch over to the other side, and I'm going to set the master rail height. Alright, so I've got my master rail off here, and I've got it shimmed up with the aluminum foil and onion skin as needed. These are all different measurements. Kind of dips down low here and then comes back up. Right at the end, I think it's kind of like bit off a little bit, probably the machining operation originally. But same way I did the other side, and it turned out really good. So we're going to put the rail down, and then we're just going to check it and see where we're at. Alright guys, well, I've got the height set on my master rail, the height set on my sub rail, and they're within 2/10 all the way around. Actually, there's only about one spot that might be a little close to that 2/10. Everything else is really good. So I've got my indicator here set at 0. I'm going to move to the other side here, hopefully without dropping this and messing it up like that. There we go. You can see we're at 0, and let me move it down. It's going to be hard to hold this and move it, but let me see if I can get you a shot here. So you can see we're right here, we're at 0. Good there. Really happy. This side was nice and flat pretty much. It was just kind of at a taper, where this side had a dip in there, and so I wasn't able to get a combination of shims to make it perfect, but most of it's within a 1/10. There's one spot I think that's around 2/10, which is good because the height between block to block needs to be 0.00032, and we're well within that, so I'm really happy. Next, I want to make sure that the rails are parallel. Alright guys, well, I'm out in the shop this morning and I'm finishing up the linear rail installation for the Y-axis. I just got done checking for parallelism on the Y-axis here. Now for the RG series, we're using light preload Z0 blocks, and for the RG15 we need to be within 5 microns. So I'm out here checking that right now, and let me show you what I've got. I've got my indicator set here. If I can do this, hold on. Pretty satisfied overall with what we've came up with. We're well within the 5 microns there. Also need to make sure that the top of the block on this side is the same as the other side. So I've checked that off the top of my surface plate here on both sides and got those within specifications. Now the specifications for that height is, let me see here, S2, and there's a formula that you have to work out, and I did a spreadsheet on that because it all depends on the center line from one rail to the other and what that distance is. For me, S2 needs to be a little over 3/10 or 8 microns, and the same for S3 dimension, which is the height from one block to the other on the same rail. So let's check that, and I'll show you what we got on that. We need to be within the 3/10. Pretty happy with what we came up with on that. So let me show you that. Alright, so over on this side, this was my highest point, so I used this for my 0. And then all I did was I just kind of slid my block down, went around, and checked to make sure that it was the same height all the way down. And you can see we're well within the 8 microns, give or take. And then I had to check the other side here and get it within the same height. Let me see if I can do this here. So you can see we're within a micron there, so 2 microns. I think this indicator is a 2 micron indicator, so. Really happy with the way it turned out. It was not an easy task. It took a lot. I've got a lot of hours in this trying to figure out the best method to A, check it, and B, get it to be consistent and right. You're dealing with numbers that are so small that it's just very difficult to not accidentally bump your indicator and throw something off. But you can see that I'm well within the 8 micron. That first little mark there is the first long mark there is 10 microns. So yeah, it's been fun. I had to pick up, my main problem was trying to find shim stock that I could use, because when I was going along checking my rail height, just like I showed you there, I was you know, several tenths out. At some spots here it dipped down on this side about 6-7 tenths, and I didn't have any kind of shim stock that would accommodate that. I was using tin foil. Now, one thing about tin foil is just your thin stuff. Your standard tin foil is about 5 tenths. If you get some heavy duty tin foil, then it's about 1/1000th. That wasn't good enough. I needed something that's going to get me down within the 3/10 specs that I could get. So I found online a gentleman on eBay that was selling this onion peel. Now this stuff is, this right here is 2/10. This is very, very thin stuff. It's supposed to be oil and coolant resistant, water resistant. I picked up some 6/10, so I would have a 1/10 increment there. I got some 2/10, some 3.5 tenths, 4/10, and some 3/10. I figured I already had 1/1000th with the tin foil, so I didn't need that. And it actually worked out, as you can see with the checks here. It actually worked out really well. I just kind of shingled it underneath the rail there as I needed it along there, and used a combination of tin foil and onion peel, and really thin stuff. I mean, we're dealing with numbers that are very, very small here, and stuff that I'm not used to dealing with. But you can see, I mean, it's almost clear, this 2/10 stuff here, and really satisfied with the overall way it turned out. The onion peel worked great, got me within the specs I was looking for, so I couldn't be more pleased. I can wrap up now with the y-axis, start taking some measurements on the width of my 2 linear blocks, so I can kind of finalize my saddle drawing. Gonna go ahead and I can do that while I'm also working on mounting the rails for the table and the column. kind of worked out well. Thanks for watching, guys. Please subscribe to the YouTube channel if you have not. If you have any questions or suggestions, as always, feel free to comment. Thanks for watching, and most importantly, be safe.